Again, this is another question we received from you guys, and it fits kind of well into my schedule because it's easy to answer and I'm currently on the road for a project. So here we go with another quick tip, how to activate vellum grains. In order to do that, let's just create some vellum grains by dropping down a box, diving in there, and maybe scaling up its size to be 5 units, like this, and then dropping down the vellum configure grain to fill this box with grains by checking create points from volume. What I want to do is dial back my grain size a tiny bit. I'm on a laptop this time, so another experiment. Let's see how well it simulates. And let's check jitter scale to break up this uniform distribution of points of grains here. So after a few iterations, you can now hear my laptop whine a bit. And that's the initial grains configuration which we're going to work with. By default, I'll just wire this directly into a vellum solver. And what I'll do immediately is dial back my constraint iterations to say 10 and increase my substeps to maybe 5. Again, for grains to work, you need at least 5 substeps, but you can dial back the constraint iterations to a really low value. Next, let's, in this vellum solver, just check the ground plane here and move that down to say -1. And if we simulate this now, after just quickly saving this, and of course checking real-time toggle, we can see kind of our expected behavior, all those grains falling down and bouncing off of the ground plane. So how do we activate them now? Or rather, how do we deactivate them in the first place? That's done pretty easily, just using a point wrangle. Wire this in our geo stream here, and just set our grains mass to be 0, because then they will be automatically deactivated by vellum, as well as the old school grain solver, by the way. All right, let's resim this, and all those individual grains stay in place. However, how do we activate them now? Well, for that, I want to use a group, and out of this stream here, I'll just drag out a group node, and in this case, I'll just uncheck the base group, set this to points, call this activate, and then use the bounding region, in my case, a bounding sphere, which I will animate through these points here. Let's just animate its center, somewhere there, move it a bit up, keyframe this, and maybe on frame 36, move that over and down a bit. So what I have here is just this group wandering through those points here. Now to activate those grains while we are simulating, what I actually want to do is dive in my vellum solver here and drop down a pop wrangle. Again, grains are just pops, particles, and I want to set this pop wrangle up to have its inputs, its second input to be a sub, namely the group sub that we just used to group those individual points. So let's point it to exactly that, group 1 here. And now I want to check if the points which come in through this second input slot, through the group sub, if they are within this activate group. So let's check if those points are in the point group, and we can do that with a function called inPointGroup, which just as an argument takes the second input. That's the one with the ID 1. We want to check if the points are in the activate group. And the neat thing about this is, as we are not changing point counts here, we can just use our current point number for our grains to check if this grain has been activated. So if this is true, so if this is 1, then we can set the mass of our grain to 1. Okay, let's save this, head up again, highlight our vellum solver, and simulate this. So with my laptop roaring, we can now see that these particles behaved as we wanted to. Again, let's replay that. Yeah, and that is looking nicely. One thing that sometimes might occur is that some of these particles up here that hadn't been activated still shift, and that is due to the vellum solver substeps here. So if you see some shifting here with the deactivated particles that still have their mass set to 0, then just increase the substeps here, at the cost, of course, of longer simulation times. And, well, that's about pretty much it. There is not much more to activating grains or deactivating grains. Really simple technique. However, that can yield very, very nice results, especially when you interact or trigger those particles through other dynamic simulations or other vellum simulations for that case. So, really quick tip, this time recorded on a laptop on the road. As always, we're intrigued to see your guys' artwork. And until next time, probably at a proper workstation then, it's cheers and goodbye.